Let's look at the operation of a basic transmission. To do this, we will build up a simple transmission using basic gears. When a manual transmission is in first gear, the small gear on the input shaft drives a larger gear on the counter shaft. This reverses rotation and provides a reduction gear ratio. The counter shaft then uses a small gear to drive the first speed gear on the output shaft. This provides an additional reduction gear ratio and also changes rotation back to the direction of the input shaft. The first speed gear then drives the output shaft. When the transmission is shifted into second, the same actions occur, only the ratio between the counter shaft and output shaft gears are changed. In third gear, which is direct drive on our simple transmission, the input shaft and output shaft are locked together, providing a 1-to-1 gear ratio. To get reverse, our simple transmission needs the addition of an idler gear between the counter shaft and output shaft gears. This reverses rotation of the output shaft, enabling the vehicle to back up. So now that we have a basic understanding of what happens inside a manual transmission, let's look at some of the components that make this operation possible. You'll recall that the majority of gears in a modern transmission are helical-type gears. Since these gears are always meshed, all the gears inside the transmission are rotating whenever the input shaft is turning. Many of these gears are not splined to the shafts that they ride on, so they rotate freely as they are turned. To use any gear to drive the output shaft, the gear must be locked to the shaft that it rides on. This is done by the synchronizer. During operation, the gear and its shaft are often not rotating at the same speed. The synchronizer makes the gear and shaft rotate at the same speed using a blocking ring. This prevents gear clash during shifting. Once the gear and shaft speed is correct, the synchronizer sleeve slides over small clutching teeth on the side of the gear. Since the synchronizer hub is splined to the shaft, this locks the gear to the shaft, letting the shaft transfer torque. This action occurs when the driver moves the shifter. This causes the shift rail to move the shift fork, which fits into the synchronizer sleeve. Let's look at the power flow of the M50D manual transmission that is used in many Ford cars and light trucks. In neutral, the engine drives the input shaft. This drives the input gear and countershaft input gear. However, since the three synchronizer hubs are centered, no gear is driving the output shaft, and no power is transferred out of the transmission. When the transmission is shifted to first gear, the first and second synchronizer sleeve moves rearward and engages the first speed gear on the output shaft. This locks the gear to the output shaft, causing the shaft to turn in gear reduction. In second gear, the first and second synchronizer sleeve moves forward and locks the second speed gear to the output shaft, thus driving it at the second gear ratio. To achieve third gear, the 1-2 synchronizer sleeve is returned to the center position, then the 3-4 synchronizer sleeve moves rearward and locks the third speed gear to the output shaft. Fourth gear in the M50D is direct drive, so the 3-4 synchronizer sleeve moves forward and locks the input and output shafts together. This provides a 1-to-1 gear ratio out of the transmission. Fifth gear is an overdrive ratio. On the M50D, the fifth reverse synchronizer sleeve moves forward and locks fifth gear to the counter shaft. Since the fifth gear on the output shaft is splined to the shaft, the output shaft is driven at an overdrive gear ratio. For reverse, the fifth reverse synchronizer sleeve moves rearward. This locks the reverse drive gear to the counter shaft. Torque is then transferred to the reverse idler gear that is in mesh with both the drive gear on the counter shaft and the driven gear on the output shaft. The idler gear reverses rotation and drives the reverse gear on the output shaft and the shaft itself in reverse.